So let me try and explain all of the index and log laws in that sense. All right, for instance, what does this mean as an identity, right? What does it mean in terms of growth and of time? Think about it for a second. Think about what all the pieces are here, okay? The idea is that if I'm growing at a rate A, okay, and if you let it grow for one time period, okay, how much bigger will it be at the end of that time period? Answer, it'll be 8 times bigger, okay? Now what does that mean over here if I rewrite this, okay? What's the corresponding log law for that index law? Because all the log laws are just rewritten index laws.
Log A base A equals 1.
Good. So if I've got something, right, it's growing at rate A, and you ask me the question, well, how long will it take for me for it to be 8 times bigger, right? And my answer is, it'll take one time period, okay? Now let's think about another one. How about this identity? Okay, what does that mean in these terms? I've got something and it's growing at rate A. What does the 0 indicate?
Hasn't grown yet.
It means I don't give it any time to grow. Okay, so 0 time has elapsed. So this is my starting point. Okay, and the starting point is it's at size 1, as in 100%. Okay, it hasn't gotten any bigger, hasn't gotten any smaller. It's just there it is. Okay, so therefore the log law that goes with this is log base A, base becomes the base of 1 is equal to 0. So think about it again, reword it. I've got something and it's growing at rate A. How long will it take me? So this is a time question, right? This whole thing is time. How long will it take me to be 100% of the size of what I am right now? Answer, it doesn't take me any time. I'm already there. Does that make sense? Okay, let me keep going. This is where it starts to get fun, okay? What about, let me think about this, okay? A to the power of minus 1. What does that mean? That's 1 on A, right? How do you rewrite this? What log law goes with this? Maybe I should ask this instead. What does this mean in terms of growth and time and rates and all that kind of thing? This means I've got something, it's growing at rate A. What does minus 1 correspond to?
Minus 1 back on time period.
I'm going backwards in time. Going backwards in time, okay? So what effect does that have on my final growth? Okay? Well, for instance, suppose my growth rate was 2. Okay? Well, if I'm doubling, right, and I go backwards in time, 1 unit. Going backwards in time. How big was I 1 unit ago? Namely, I was half the size I was before, right? And then you come forward and you're like, oh, I'm back to normal size. Okay? So therefore, I think about this as logs. Okay? Logs. If I say, think about this. This gets a bit trickier. If I say this, let's slap. What should I put? This will be a little bit different. Okay, just so I can try and illustrate it. Okay, I'm growing at rate A, and I want to get to X times bigger than I am. Okay, but there's a minus sign. So what does that signify? Well, you guys know how coefficients work at the front, right? This is going to be equal to, coefficient becomes the index, right? So this is going to be log base A of 1 on X. Do you agree? Does that make sense? Now what does that mean? What does this correspond to? Remember, logs, all of this is about time. Okay? So when you see a minus in front of a log, that means you're going backwards in time. Back to when you were 1 over X in size, like say half the size that you are now, because you're growing. Okay? Okay, let's think about this. Let's think about how logs go together, because this is where it gets confusing. Okay? I'll give you a concrete example first, because that might be a bit easier. If I say, want to grow to 6 times my size, I'm growing at rate A, and I want to get 6 times bigger. Okay? I can think of that as the time it takes to double in size. Okay, so now I'm twice as big. And then the time after that to get 3 times bigger. Right? So if I grow twice as big, take that time, and then grow 3 times as big, and take that time, and add up those times. That's this, right? You see, each of these refers to a time. Okay? So when you add up these times, because the growth multiplies. That's why you're going to get log of, say, mn. Okay? This is the product rule. Is equal to m plus n. These two times are separate and they're building on each other. Does that make sense? Okay, let me give you another example. Let's take this line, okay, and just do some simple arithmetic on it. Let's do this. Subtract this, right, from both sides. Now, remember, I said this is all about times, right? So what does that line mean? Remember what we said up here, right? If you see a minus in front of a log term, right, that means you're going backwards in time. Okay? So let's look at the left-hand side. This amount of time is the time it takes you to get 6 times bigger. Okay? So that amount of time elapses. Okay? But then there's a minus sign, which means you go forward and then back in time, the amount it takes to double. Right? Does that make sense? So if I've gone forwards this amount and then backwards this amount, so I've grown 6 times in size, and then I've halved myself, right? Another way of thinking of it is like this. You see what I was doing? I've turned it positive now, okay? Time it takes me to grow 6 times bigger, and then the time it takes me to grow half my size, which happens to be negative, right? That's going to be, I'm going to be 3 times bigger, right? Which is where we get the division law, okay? So you can say log of m minus. Okay, does this make sense? So I think the big breakthrough that you need to get is that when you see log equations, think time, think duration. How long does this thing take to get to the size that it is?